Fouling just means that a membrane gets dirty. Especially here we're talking about fouling in reverse osmosis membranes. There's 4 types of foulings, right? The first one is what's called the particulate fouling. And a very good way to avoid this is by having a good pretreatment, right? For example, if you use ultrafiltration, typically as a pretreatment, it will have a 20 nanometers per size. That means that every bacteria, colloid, anything that it's particulate, right? That it's kind of this macroscopic particulate matter will not pass through it. So with a good pretreatment, you can kind of solve it. The second one relates to scaling, right? Scaling basically means that in a membrane, you are removing water. So salts are staying, and at some point you will overcome the solubility of these salts, and they will start to precipitate. And sometimes it's not as easy as that, because there's the induction time, right? The time that these salts need to form aggregate, form crystals. It's also fracturing. So sometimes you can operate above the solubility limit if this induction time is short, right? This residence time. But still, this is pretty much well solved if you design it well and use antiscalants if needed, right? And then there are 2 remaining types of foulings. There's the organic fouling and biological fouling, and they are a bit independent. What does it mean? That means that organic fouling mainly means that water, for example, from a river will have humic substances, right? Organic matter that is dissolved, and as you start to permeate water through the membrane, suddenly you will have it covered with a layer of organic fouling. Typically, you realize about this in a plant, because as soon as you start operation, you will start to see the normalized flux or the energy increasing, right? And reaching kind of a logarithmic until it kind of stabilizes. So applying a good safety factor, we call it a fouling factor, you can in the projections you can have it a bit under control, right? At the end, it's just that you need more energy to filtrate the same amount of water. And then comes biofouling. Biofouling, it's of these 3 types of foulings, the more challenging one, because what happens is that there are certain bacteria that they have evolved over centuries, much longer than humans are in the planet, that when they find a solid surface, they will just attach it, right? And as soon as they receive nutrients, and this is the perfect example of membranes, you are having a constant amount of flow, right? You are bringing them food, right? Burgers over time, and they keep eating, reproducing, right? They will start after some weeks, 1 week, it depends, 2 weeks, 3 weeks, 1 month, depends really on the type of water, but they will start to form a kind of a gel, right? And at the end, there's no problem that there are membranes there, right? We also rely a lot humans in biofouling when eating and all that, no? But the problem in a membrane is that this gel occupies the space, and at some point, all the space that the water has to flow through the membrane will get blocked because of this gel, right? And this is a problem because if you don't clean it effectively, if everything is stuck, water will not be able to pass, so it will start to mechanically deform, right, and damage the membrane. So that's why it's so important. Typically, you measure what we call pressure drop, which is the difference between the feed and the concentrate pressures. And that's why biofouling is so prevalent, and it's a problem. And it's difficult to clean once you have it. Typically, you can clean it. If you clean earlier, it's better. Sometimes if you wait too long, it's very difficult to clean. And especially because in a membrane, bacteria find places to shelter, like between the feed spaces, right? What chemicals is very difficult to flush. And we need to remember that in reverse osmosis membranes, we cannot use bleach. We cannot use chlorine because we'll remove the polyamide. In ultrafiltration, it's very easy. You just put sodium hypochlorite and everything's clean, right? Like the toilet at your home. But in reverse osmosis, we cannot do that. And that's why it's that problematic. So once we understand why biofouling is that problematic and it's very prevalent, there was a study done a while ago by Genesis, I think by Nuria Peña, that analyzed 1,000 samples and found out that the majority of it, 85% or 80%, were because of biofouling. So very prevalent nowadays. We need to see what we can do to deal with biofouling, right? And for that, I like to refer to the biofouling triangle.